to give you some idea about, we left off the other day talking about functions. In other words, I gave you an equation, y, I think it was something like this, y is equal to x squared plus 2x plus 3. It could be of any sort here. It could be x to the 5th, I don't care. But what they said, let's change this a little bit and let's call this a function rather than just a variable y. So what they did is they said, okay, if we're going to do that, then we'll have to rename it f of x. In other words, it's a function of x. And the reason they could do that is because there's nothing over here except the letter x. Okay? If you wrote this as a height with time, it would look like this. Y'all remember working on this problem just not long ago. So that would be what? That would be a function. The height that an object goes is a function of what? Of time. In other words, as the seconds roll by, the thing does what? It starts to go up, 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 and then it does what? It reaches its top point, and it starts back down. So, but I want to make sure you understand what it means about having a function versus just an equation. And it's really a convenient way to do this. You could say, what is the height when t is 2? In other words, when the time is 2 seconds. So you'd write it like this. What is h of 2? H of 2. Or f of 2. So it's sort of a convenient holding place for the variable, the number that you're going to replace the variable with. Does that make sense, everybody? Now, I think in this first section, they're going to give you some different points and things of like this, 6, 2, 3, 4, 5, 2, something like this. You can have 5, 2, like this, 7, 3, whatever. And they may ask you, is that a function? And the way you determine if this represents a function is just look at the first number in each one of them. Look at the very first number. Okay? Now, if you have two different first numbers and the second number is the same. If you have the first, let me say this again. If you have the first two numbers are the same with a different number in the second column, then that's not a function. Okay? Now, you could have two different first numbers that have the same number in the second column, and it is a function. So take a look at this. What if we did this? F of x is I'll do a really simple one. That's a very simple one there, and you can tell very quickly that you could say this. You could say x, f of x. Okay. So when x is 0, this is 0. When x is 1, this is 1. When x is 2, this is what? 4, right? When this is 3, this is what? 9. When this is minus 2, this is also what? 4. When it's minus 3, it is also 4. So you can see quickly that this to see if this is a function, if you're just given these points, you can have actually what? You can have the second number being the same. Look at this, and this. But yet the first number is what? Entirely different. That is a function. So when is it not a function? Is when the first number is the same, and you have two different numbers in the second column. In other words, this, for example, if you had this, if you had a 2 and it's 4, is that a function? No. No, because this type of problem would fit something like this. Okay? When I go out to 2, that's what? It's also what? Does everybody see that? And how do you know this is not a function? How do you know this is not a function?
Vertical line test.
Because the vertical line test fails. So a vertical line, does it only cross through the line once? No, it crosses it what? Twice. So that's how you can tell. The second way you can tell is what? The first two numbers are the same, but the second numbers are what? Two different numbers. That is not a function. Okay? Over here, this is a function, even though what? The second numbers are the same, but provided that what? That the first numbers are different. First numbers, a -3 is not the same thing as a +3. Y'all need to get off the machine and listen to what I'm saying, because hell, the grades are going to go downhill like, and go to hell in a handbag, and you're going to wonder why. Why did I fail this test, and can I retake it? No, hell no, you can't retake it. So it's a one-shot deal. So y'all do me a favor and try to pay attention. And do this for me. Write the area of the circle. Write the area of a circle as a function of its diameter. Write the area of a circle as a function of its diameter. See how many have been paying attention? Write the area of the circle as a function of its diameter. Bring paper to class. Don't come to class without paper and pen and your calculator. You might well stay home. Okay, let's see what you got. Anybody? Got it? Mr. Flower, don't tell me you don't have it.
Whoa! Hold on.
Whoa, you got it. Oh, okay, you got it. Oh, very good.
I'd make change to it, but
What that?
I'd make change to it, but it's good.
You didn't copy off his paper, did you?
No.
Oh, okay. I was just checking.
Why would I do that?
That's great, you got it. Yes, you do. Say yes. Where's yours at? You got it? Hurry up. You just have to start writing something. Come on. Y'all got to hurry. Now, don't you look at that. Get off that. Get that off that. She did. Golly.
Jesus Christ.
Google it, huh? I saw her Google it. Try it without Googling it, okay, y'all? Y'all hurry up.
Jesus.
She will.
Patience, little Jedi. Come on now.
It's a really simple problem.
Patience is a virtue.
No, it ain't for me.
Apparently. Gee, Jedi.
Get out, that ain't right. Look at what you did. Oh. Did you Google it? No. You didn't Google it. Don't you Google it? Look, Jackie. Don't you Google it? You got a Valentine's, pretty sure, what a gun, Lord. What did he get you for Valentine's? Nothing, I bet. I didn't get my wife anything. You know why?
You didn't get your wife anything? Because
No,
you don't have
no.
one. Oh, you don't have a wife?
Yes, I have a wife. Tomorrow she gets flowers and I get them at high price. You laugh.
Don't give her enough discount.
She's never got flowers on Valentine's Day. She's always got them a day later because tomorrow is her birthday.
I see what you did there.
I get flowers at high price, folks. They're high price tomorrow. You can go check and see.
You weren't supposed to.
Yeah, it might be a little dead, but that's okay. How rude. That's being what?
That's being rude. That's
Yeah,
like being born on
no.
the 26th and still using Christmas paper.
That's being very efficient. That's being very logical, folks. You gotta think logically.
I don't like these flowers, but I die anyway.
What? You gotta think logically.
I don't like
What
It's right.
No?
I got it.
I got something, but I don't think.
Kelsey got it. Kelsey got it.
That's it. Oh, you got it on Google?
No. Is that right?
Good Lord, no.
Yes, it is. He said, Lord.
Now, let me ask you a question.
Did you
Is your equation over there, on the right-hand side, does it have a D in it anywhere?
Yes. Yeah.
No. Where?
Right there. Right there. Right there.
You just wrote that one over there. Hell, that ain't no equation for no circle. You just made that up. You all look up here a second. It's a very easy problem. Y'all think, look, all you gotta do is think about this problem. You know the area of a circle is what? And you do the simple one, you want the whole circle, right? You know, it's what? It's pi times what? Well, guess what? This area is written as a what? As a function of the radius. Okay, do you all see that?
Yeah.
Yes or no? Very simple, right? Is that what I asked you to do? No. What did I ask you to do?
The diameter.
Write it as a function of what?
The diameter.
Of the diameter. How many of you, right, look, don't you look at the board. How many of you know how to get the diameter? How do you get the diameter?
2R. 2R.
You sure?
No.
Yeah. Say yes. Say yes, I'm sure. Of course I'm sure. The diameter is equal to 2R. So if you know that, folks, guess what you know? You know the diameter, right? So the diameter is equal to what? 2R. Yes or no? So R would mean if you took the diameter and divided it by 2, you would get what? You'd get the radius. Say yes.
Yeah.
Yes. Watch what I'm going to do. So simple. If I square this side, I must square this side. Yes or no? Did I hurt anybody? No. Did I hurt my equation? No. Look at this. A is a function of D is pi. What in the world is R squared? Look over there and tell me what R squared is. What is R squared?
The diameter.
What?
The diameter.
Let's turn it. What is R squared? Read it. D squared over 2. D over 2 squared. That's the R squared, isn't it? So this makes it what?
I feel like I'm doing the lights.
That's the area of a circle. Y'all look, y'all got frowny faces like you've never seen that before. What? You've never seen that before ever?
No.
I don't recall.
Because I remember the 27.
What?
Why are you looking at me like that?
I'm looking back at y'all just like y'all looking at me. So, like, oh God. Boy, that came as a curveball. Right?
More of the slider.
It's what?
There's more of the slider. I can hit a curve. But I can hit a curve.
Baseball. Talking about here.
But I threw a slider, you all. Whatever that is, I don't know.
It's not baseball.
Get out baseball. I quit playing baseball years ago. I did. I used to play baseball.
Were you any good?
I almost made the Army baseball team.
What?
Yes, I did. I was one guy short. And the guy that beat me out, I would have voted for him. Because he was from Puerto Rico, and he left me in a cloud of dust. I swear he did.
Yeah.
I never hit a home run in my life.
I'm a pretty good baseball player myself.
But I guarantee you I'd hit the ball.
Yeah.
They always used to embarrass me because guess what they would always, opposing team would always do when I'd go up to bat. They would all start to come in from the outfield and then always, here's the guy that hits the ball, he's a fast runner. And they'd always say that, embarrass me. And when my friend goes to get up to bat, they would all go out to the back of the field. Because he knew they was going to knock it over the fence, probably. But I never hit one over the fence in my entire life. Never hit a home run in my life.
Don't ever get twisted. We can't play hockey. We just choose not.
What now?
One sport.
I can't hear you. But it is sort of weird because I just gave up baseball about 10 years ago. Don't watch it anymore. Don't play it. I roomed with one of my roommates in the Army. This is the goodness truth. I wish I had kept up with him because I'm almost sure he probably played pro baseball. Because at least twice a week he slept in his bunk with his baseball glove. That's how much of a baseball, he was a pitcher. And his whole dream and his whole entire life was revolving around baseball only. That's all he talked about, that's all he ever thought about. But guess what? At least twice a week, he would always wake up with a nightmare. And he would wake me up and startle me because he would be startled because every single nightmare he had was exactly the same dream, that he lost his arm. Always, he lost his arm. They cut his arm off, or he got his arm cut off. And he would wake up screaming. Well, I mean, not screaming out like, ah, but enough to wake me up. And I always say, everything's okay, it's okay, it's okay. But I've often wondered if he ever got to play pro ball. Because that's all he ever thought about, ever.
I just want to be an ice skater more than anything. I want to be like the next Christina Yamaguchi. I just had to play hockey.
This ain't the dream class.
But I wanted to be an ice skater. It's the same thing? No, it's not the same thing.
Well, first of all, you got to get ice skates.
I know how to ice skate.
Yeah, okay, you got to get ice skates first.
I swear to God, I want to try with it.
Oh, let's go on. We got to move on. We got more problems to work. Does this problem make sense to everybody?
I know.
Now it does?
Yeah, now it does.
Now it does. And that's what, listen, that's what they mean by writing a function, like the area of a circle, as a function of D. So that means what? All you have to know is the diameter to get the area. You don't need to know the radius. It tells you that area was equal to pi r squared, right? So that's pretty much wrong too, isn't it? Let me ask you another question. Maybe I did this in this class the other day, I'm not sure. But maybe it was my other class. But how, truly, now I can give you an example of why this is important after I do it, okay? But how do you actually write the area of a circle in the, the standard old way? How should you do that? What is the absolute correct way to teach someone to write the area of a circle? How many of you know?
How do you write the area of a circle? Pi r squared.
I'll bet you most of you were taught what?
Pi r squared? No, they're not. They're round. I learned that in 3rd grade.
That's really not the whole truth of the story. And let me give you an example why, because my trigonometry class was given a problem of this sort. I'll try to draw it the best I can. I don't know how good I'll do. But that's supposedly a cylinder, okay? And what somebody did is they said, okay, and try to make this. And they actually wanted to know, can you all make this out? Did you all make that out? You've got what? You got this bucket, but it's what? It's partitioned off. What is the volume if this is what? And they couldn't do that. And the reason why they couldn't do that is because somebody told them long years ago the wrong way to find the area of a circle. The absolute correct way is this. Is theta divided by 360 degrees. That's the correct way. If you want the entire circle, then that becomes 360. So what's 360 divided by 360? It is 1, and that's what you get, okay? And because they were never shown this, then they didn't know how to do that. Because if this is a circle like this, and you only want to get what? This slice of the pie, and that's 110 degrees, how do you think you get the area if this is what? That's 8 inches. It is the area would become what? 110 degrees out of what? 360 degrees times pi r squared. And that's the way you do it. And over here, the what? The volume of this sector is cut off into sectored piece, okay? Can you all picture that as being a piece of a sectored piece? It's the V shape from the top all the way down, and they want to know the volume? And that's this question It would just be what? That's all you have to do differently. And they didn't know how to do that. And the reason they didn't know how to do that is because they didn't know how to find what? Just part of the pie, not the entire pie. You want just a what? You want just a slice of the pie, and you do that with that equation over there. And guess what? The circumference of the circle is exactly the same thing. They've always told you it's 2 pi r, right? It's really not. It is what? That. Because sometimes you may only want what? You may only want this distance here. That distance along there. Instead of all the way around the circle. Am I making sense? Because from that point, the circle is broken up. How many different ways is the circle broken up? Somebody tell me. It's broken into what?
4.
2.
A third.
1/4.
First of all, I'll give you a hint. The first way, it is broken into what? Degrees. How many degrees are there in a circle?
360.
How many?
360.
Why 360? Why 360? Hell, don't tell me the height of it's 180. I know that. Duh. A fourth of it's 90. I know that. Duh. Why 360? It's arbitrary. It's made that up. It works. It works.
We don't challenge.
The French don't break their circle up in 360 degrees. It is what? Look at your calculators. What does your calculator say on it? What does it say? What do you have on your calculators, everybody?
We have an on button.
Oh my gosh.
Got a mode where you can choose.
They break them up into what? The French break it up into 400 gradients. You have a GRAD on your calculator. Scientists and engineers break the circle up into what? Radians. Radians. Radians.
Radians.
R-A-D-I-A-N-S. Radians.
Radians.
I'm going to explain to you in a minute what a radian is. How many of you know what a... Pardon me, but I'm going to call it a rad, okay? Is that okay? I know that's not the correct terminology, but that's what they use in math as shortcuts, okay? A rad is a measure of radioactive material, but we're going to call it rad because I don't like to say radiant each time.
Okay.
How's the Army break their circle up? Anybody? Where's my Army people? Y'all, no Army people? I'll bring the paperwork Tuesday. I'll sign y'all up on Tuesday. Just line up and I'll sign you up. It's only a 2-year commitment. I'll let you buy for 2 years. It's usually 4. Tuesday over, last day.
I need to get my benefits.
No takers, huh? Well, they break yours up in 6,400 mils, M-I-L-S.
So
Yeah,
that's
smart
4
little
ways.
English.
Look, you need to know, you got to know this, folks, because look at this. If you take the circle, let's suppose that's the radius of the circle, okay? That's the radius. Y'all better pay close attention to what I'm doing and get off those damn computers. I'm going to unplug the damn thing. If I had a thing, I'd unplug the whole wall. Do they have a cutoff switch in here that cut off the whole thing? I'll fix it. Anyway, because you need to be paying attention to what I'm doing, because then if you do take my trig class, then you won't be asking stupid questions. Yes, they are stupid questions, too. What the hell, does the person get real smart right before you ask it? No. So, if that's the radius of the circle right here, and if you decided to do this, if I want you to now move along this outer line, walk along until this distance that you've traveled is exactly the same distance as this, and I go back to the center, it is 1 what? 1 radian. How many of you see that? How many of you understand what I just did? Only one person in the room, because the rest of you be lying if you raise your hand. Because I'm about to check. I'm about to check, Mr. Jackson. We'll ask him. No, I'm not. I'm going to ask somebody else. Let's see. Oh, dang. No, Mr. Flowers, I'm not going to ask you. Oh, Lord, no. Anyway, look at this, everybody. If this distance right here is exactly the same distance, so this would be what? This would also be an R, right? That correct? But this is what they usually define this as. They usually define this as what? S, meaning the distance displaced. In other words, the displacement. But if that S is equal to R, then I have made what? 1 radian of angle. 1 angle is 1 radian. It is this, I can't emphasize the importance of this. Because take a look at this now. My question next is going to be this. How many radians are there in a circle?
400?
Now, you can keep on guessing if you like, even though the answer is written on the board. The answer is written on the board. It is written somewhere on the board.
6.
How many radians are there in a circle?
4, 2.
It ain't on the board anymore.
36.
I ain't gonna put it back up there. Till now. If you look at this, everybody,
12.
the circumference, y'all hush, the circumference of a circle, which means if you go all the way around, is equal to what? So I'm asking, how many of these, if that's R, that's another radius, right?
6.
That's another radius right there. Yes or no?
6.
How many R's are there in a circle?
6.
It's written on the board, you all.
2?
Folks, do y'all see there's 2 pi radiuses in a circle? How many R's are there in a circle? 2 pi, which is 6.28. So how many rads are there in a circle? 6.28. There's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And that point right there is part of what? 0.28. Because 6.28 is 2 pi. Do you see there, everybody? There's 2 pi radiuses in the circle. So every time you go 1 radius, you've gone 1 radian. Am I making sense to anybody? Some of you know? That doesn't make sense? I don't know any other way to tell you. So look, if you had to do this, what's this, everybody? If you found the circumference of a circle, okay? Let's suppose that the circle maybe was not, whatever. We know it's what? You remember them telling you this? You remember them telling you this? That the circumference is 2 pi r? Yes or no?
Yeah.
Well, this is where the wheels came off the wagon in trigonometry, because I said, look, sometimes this may not be measured like this. This is only if it's what? If theta out of 360 degrees, right? Remember me telling you that a second ago? Well, now, guess what? The measure of the circle is no longer in degrees, but it's in what? It's in radians. So it's theta out of what? 2 pi rads in a circle, and look what happens. So circumference is equal to what? Just theta r. Look how simple it becomes. It's so dang simple. So you better hope that all of them are measured in what? In radians. You think now you see why the scientists all do it in radians? Yay? No? Yes? No?
Pretty.
The same way with an area. Is that equal theta out of 360 degrees times what? Pi r squared, right? Yes or no?
Yeah.
But no, this time around, I'm not giving you the circle in what? Degrees. I'm giving it to you in what? In radians. So that would be what? Theta out of what? 2 pi rads. And look at this, everybody. Okay. So the area becomes what? Theta r squared divided by what? So it's so simple. You can get the whole circle, or you can get what? You can get just part of the circle. Let me back up a second to this circle. That's a bicycle wheel, and that's a spoke, okay? That's the spoke. And you can put yourself put your a bug there, a ladybug, or a dot or something. If you spin that wheel around, which dot is going faster?
Outside. Outer.
Some of them haven't ridden on a merry-go-round before. You have to remind them. Some of them haven't ridden on a merry-go-round. I can tell. Have you? Y'all not ridden on a merry-go-round? When you rode on a merry-go-round, where did you get?
Sit.
Closest to the center or where? No, because you hung on what? You hung on the outside as far out as you could because you wanted to do what? You wanted to live dangerously. Whirling around because why? If you stood up in the circle, you got up there towards the center, you'd just be what?
Lame.
You wouldn't feel like you would go. Hold it a second. That's the same spoke. That's the same spoke. How can one of them be going faster than the other one?
You feel faster when you're on the outside. And
You don't feel faster, you are faster. Feel faster. Crazy.
So are you not faster?
You don't feel faster, it is faster.
How are you faster
Because
on the
it is.
outside rather than the inside?
You have to go back and ask the simple question.
That doesn't make
In
sense.
what measure are you talking about traveling? You better listen to me carefully, because there's two ways to measure the velocity of that ladybug.
Speed.
You can measure the velocity of this ladybug by doing this, if you said, you know what, this ladybug, if this is, say, 100 inches around there, 100 inches all the way around, and suppose this one is only 30 inches around it. From here to here is 30 inches. Now, if I spun that wheel one time around in a second, this ladybug on the end is going 100 inches per what? Per second. The ladybug sitting right here is going a total of what? Period, and that is called linear velocity. That is if the ladybug falls off, the one on the outer edge is going to hit the ground going what? 100 inches per second. If the one on the inside falls off, they go hit the ground or whatever, hit something going what? 30 inches per second. That's called linear velocity, folks. Period. But you have to acknowledge the fact that when you spin that wheel around one time in a second, both ladybugs have traveled 6.28 radians per second. Both of them traveled 6.28 radians per second. Do you see that? So it's really according to what type of measure you're talking about. Are you talking about linear speed? Or are you talking about something called angular speed? And angular speed is written like this. It's a funny looking W. It is equal to what? The way you do this is what? So many what? So many rads per what? Per second.
That's angular.
So we went, that's called angular. It's a funny looking W. Angular velocity, folks. It's very, very important. When I become dictator, I have to be the judge in a courtroom. And all these people come in there and they got this ticket because they were going too fast, and they go say, well, Your Honor, you know, I got different size tires that came on the car. I got those 24 inches or whatever, the 22-inch wheels, and my speedometer is not right. I said, well, that's very good. There's the blackboard, drag it over here in front of me and show me why. Mathematically. If you can do so, then guess what? You don't have to pay the damn ticket. But if you can't prove to me, mathematically, what you're saying is true, which is false anyway, then you're going to pay that ticket, but it's going to be double. I suppose most of them are going to pay the ticket and go on. Right? Go to court and try to argue with the judge. They're going to argue with me because I'm the dictator. Pay the fine, go on home, go to jail one.
Can it be proven? Can it be proven? Can it be proven?
Oh yeah. But yeah. So let me ask you a question. Is there a relationship between linear velocity and angular velocity?
No.
Say yes.
Yes.
Of course, I just showed you yes. That poor ladybug on the end is going what? 100 inches per second. The one closer in is going what? 30 inches per second. And they're both going what? 6.28 radians per second. Both of them. So that's angular. The other one's what? Linear. Wow, you're talking about the same bicycle wheel with two different methods of measuring. So of course they've got to be what? A relationship between the two of them. Yes or no?
Yes.
How do you calculate velocity? Velocity is some distance s divided by time, right? Yes or no? So many feet per second, so many inches per second, so many miles per hour. Yes or no? What's that called? Linear speed. Linear speed. We also know this, you all. We know that theta, this is in radians, is what? Is S. This is S, remember? Everybody told you this was called S?
Mm-hmm.
Say yes. Divided by what? I'll make a capital R, I guess. Is that right? Because if S is equal to R, we got 1 radian. Right? So what's this? Omega is equal to so many rads divided by what? Say yes. Say so many rads divided by time. So many 6.28 rads per second. We spun it all the way around. In 1 second, the angular velocity of those ladybugs was what? 6.28 rads per second. Everybody see that? Yes or no? You see that?
No.
No, what do you don't see? Can I help me out? Angular velocity is measured out. So many rads per second. There. Rads per second.
Okay.
Linear speed is what? So many inches per second. Feet per second. Right?
Okay.
We've always done it that way. Now, we've also identified that theta was a rad. A rad, so many rads is what? Is this distance S divided by what? By R. It's S divided by R. Remember this? Whatever distance this is right here, if this is R, right here, and that happens to be R, that's 1 radian. But this may be 2 R's. That'd be what? Be 2 radians. Making sense? But look at this. What is this right here? Guess what I'm going to do? I'm going to replace this with what? Everybody see that? So omega becomes what? Right? Say yes. Look at this, everybody. Guess what this is right here? Guess what that is? What is that? Some of you don't care what I'm doing on this board. So this becomes what? Omega equals what? So that leads us to believe that what? Omega times R is equal to what? That's the relationship between angular velocity and linear velocity. Am I making any sense whatsoever? At all? No? How many of you don't care? I don't. It's really pretty neat stuff, though. See, look, everybody, sometimes this may be given to you in radians, not in degrees. But yeah, what do you do if it's given to you in radians? What's he doing?
Huh?
Huh?
I'm just sitting here.
See, you're sitting here. Golly. You got a clue what I just started to say?
Ask him to repeat it.
Yeah, man.
No, you don't even have a clue what I said, talked about.
You repeat it.
And when I asked you, did anybody care? You didn't even say a word either. I even asked you, does anybody, you care? He didn't say that.
Should've raised your hand.
He didn't either.
Hockey boy.
If you did, you raised it for him. I didn't really mean to get this far off the topic today. But I felt like that it's something that you don't need to leave this technical school without knowing. You don't need to leave this technical school, regardless of what field you're in. I don't care what field you're in. $16.50. Do you think by any chance that Leonard Euler, the young mathematician, had any clue about the Euler identity theorem? That what he actually discovered in the 1600s is now being used as security codes and credit cards and any other form of identity protection? My son filled our whiteboard last night, showing me the proof, and I thought that was the neatest thing. That Euler's identity is being used. And he showed me how, with N and E, that I can now break a code that he sent me. Incredible, incredible. Leonard Euler didn't know anything about computers. Never had a clue that all the stuff that he was doing was going to one day become so valuable that we could not do what we do today without it. They don't know of another way to do this. And do it in such a manner that is protected. It involves multiplying two very large prime numbers. Wow. Anybody see the movie called A Beautiful Mind?
Yeah.
Anybody? How many of you saw that movie? You know what it was about? Remember what it was about?
Schizophrenia? I mean, it's schizophrenia, but it was a mathematical genius. And
Remember his name?
decoding it. There's a real person that is, I forget who it was.
His name was John Nash. John Nash. True story. True story. Incredible person. What else happened? What happened to him in the movie? You remember what happened? What did he win?
Nobel Peace Prize,
Not the Peace Prize. Nobel Prize.
Huh?
He won the Nobel Prize.
That's what I said.
You said the Nobel Peace Prize.
Oh.
It's Nobel. They give Alfred Nobel, when he set his prizes up, he made it available to different fields: chemistry, physics, economics, literature, on down the line.
Yeah.
So John Nash, the great mathematician, won a Nobel Prize. My question is, how did he do that when Alfred Nobel specifically put in his will that they've tried to get changed and they cannot because it is cut in stone that a Nobel Prize will never be given in mathematics? Why not? Because he suspected his wife of seeing a mathematician. True story. And he said he will never give one in mathematics. So what did John Nash get one in? He was a mathematician, right? Hey, what?
Nothing. Keep talking.
Economics. It is where they applied his mathematics to economics that he won the Nobel Prize in economics, not in mathematics. You can't win one in mathematics. But one person won 2 different Nobel Prizes in 2 different fields. Who knows the answer to that one?
Albert Einstein.
2 different fields.
Obama.
Oh my God.
Stand out there.
Isaac Newton.
Isaac Newton.
Oh, no, I think it was around then.
Dr. Linus Pauling.
How are we gonna guess that?
Dr. Linus Pauling won one in chemistry,
I don't get
and he won the second one in, guess what? Peace. He would have won the third one because he already had solved. Shut up! I'm talking, David. He'd already described exactly what the double helix looked like long before Watson and Crick. The only reason and way he didn't win it is because they would not let him travel outside the United States to get to the machine to prove his theory. And Watson and Crick had access to that machine. Why would they not let him travel? Because of some damn people go what? McCarthyism.
Do you think Rosalind was robbed by Watson and Crick, or do you
Watson
think...
and Crick got the credit for the double helix.
Yeah,
But he already had figured out the whole entire picture.
the woman named Rosalind?
Rosalind?
Rosalind, she came up with like the actual formula for it.
She
Yeah.
took a picture of the...
But he had already done this.
Pauling did?
Yeah, Linus Pauling had already done so. Because he was protesting the nuclear weaponry that we were testing above ground, that labeled him a communist, un-American, even though he won the Nobel Peace Prize for what his work and his effort to get it stopped, because he knew the dangers of doing what they were doing. The government was doing what? Testing all sorts of weapons above ground.
Where do you stand on nuclear energy? Are you pro-nuclear energy or against nuclear energy?
Here's the thing about it. It's very, very simple. The solution is very, very simple. And that is, you must invest in some way to produce instead of fission is fusion. If you can produce that, where you're converting hydrogen to helium, then you'd have all the power that you'd ever dreamed of. The same power that's stripped into what? When the two particles run together and they get pushed together, the two hydrogens become pushed together. The hydrogen expels an electron. Well, this fusion process produces two particles, a positron and a neutrino. That neutrino is a ghost-like particle that goes off. They go slam through our Earth, we know. They go slam through the Earth, but they're ghost-like particles. But that positron, guess what he runs into? That electron that got stripped off is negatively charged, and they annihilate each other, creating a tremendous amount of energy. So now you got two nucleuses hooked together that's created some mighty, mighty powerful stuff, and they bump into two more that's done the same thing. And then guess what? When they bump into it again, another massive power is being given off. Now you got four. It expels one of them. And guess what that one does? It goes out there and finds another loose one, and they ram together, and the same process takes all over again. It's called fusion, not fission. You need to produce that. You wouldn't have to worry about it being dangerous. So,
Do you want us to write a paper this semester about something in math? You had me do that when I took it
yeah,
before.
thank goodness that somebody's read the syllabus.
What?
Some of you read the syllabus, I can tell, because it does say what? At every course you take, you have to write a paper, right?
Right.
And I do expect you to write a paper. I do not want the paper to be longer than probably a half a page to 3/4 of a page long. Doesn't need to be any longer than that. What I'm looking for is grammatically correct sentences and not something copied and pasted like they used to do.
Mm-hmm.
Students used to copy and paste from a URL, and they wouldn't even take the URL off the dang paper. And they said they wrote it. Give me a break. I had them one time see the movie, A Beautiful Mind, and then write me a page paragraph about it. Guess what I would always get? I would get the same word for word copied off the back of the DVD. And I say, are you telling me that I've not read this? That you wrote this? Yes, I wrote that. I said, well, hell, that's funny because it says the same thing on the back of this DVD I have here. So how'd you write this? Boy, you wrote the same words they wrote.
Coincidence?
Boy, what a coincidence.
Do you
And I
want,
wadded up, threw it in the trash can, and tell them to write about something else.
do you want like a when I
Yeah,
write
I'm
this
looking
paper,
for
what are you-
grammatically correct stuff, and I want you to just write me something that you thought was neat about math, or something you learned in this class, or something. Because I have to make it specific, otherwise students would go to the URL and copy something off about math.
Do you want me to write about like a theorem, or can I write like a
You
biography?
can write anything you want to.
I could do like the biography of Euler or something like that.
We can write about ourselves.
Yeah, well, I prefer that you don't write about a mathematician because a lot of times students will just go to the Google and copy and paste a paragraph about it. You know,
So no
like I've never read that before. You know.
So no biographies, more.
Well,
about
yeah,
the
pretty
theorem?
much just write up something on your own.
Okay.
Half a page, double spaced,
When is this due?
end of the quarter,
Okay.
end of the semester.
Yeah, we should do some attributes.
What I'm actually looking for, and this is, let me tell you why this all came about, then I'll get out of y'all's way. Mr. Jones got really, really tired. And Mr. Smith got really, really tired too of reading emails from students that was so illegible, written, grammatically incorrect, you couldn't even read it. You're mean.